Alright, let's look at the homework 16.8, problem number 6. Alright, so let's look at this problem. Alright, so f in this case, f is going to be, first component is y plus 7 sine of x, and the second component is z squared plus 3 cosine of y, and the last component is x cubed. Right? So let's go ahead and find the curl of this. So we have a curl of that is going to be vector I, vector j, vector k. Alright, so you have a y plus 7 sine of x, and a z squared plus a 3 cosine of y, and x cubed. Alright, so this is going to be, so first component is going to be, let's see, I forgot to put the partial here, partial with respect to x, partial with respect to y, and partial with respect to z. Right? So partial of this with respect to y is 0. Partial of this guy with respect to z would be 2z, so it's going to be minus 2z. Right? Let's see, y component is going to be partial of this guy with respect to z is 0, minus partial of x cubed with respect to x would be negative 3x squared. Alright, then last component will be partial of this with respect to x is 0, minus partial of y with respect to y plus 7x with respect to y, so it's going to be negative 1. Right? Alright, then the surface is z equals 2xy, so you can use the parameterization. Vector r is going to be, we can use x and y, and then you can use 2xy. Alright, so we can find r, right, partial with respect to x, cross product with vector r, partial with respect to y, so this is going to be equal to, right, again, the vector I, vector j, vector k. Right, partial of this with respect to x, we're going to be 1, 0, and 2y. Partial of this with respect to y would be 0, 1, 2x. Right, so this is going to be equal to, right, first component is 0 minus 2y, so you have a negative 2y. And this component would be 0 minus 2x, so it's negative 2x. And the last component is 1 minus 0, so it's going to be 1. So we have that. Alright, so what we're getting is this is going to be equal to, alright, so you have, so using Stokes Theorem, we know that it's going to be a double integral, right, over the surface, so let's call that surface S, right, then the curl of F is going to be negative 2, actually z is equal to 2xy, so I'm going to put the xy there, so it's a negative 4xy, so you have negative 4xy, right? Then you have a negative 3x squared and a minus 1. Right, then we have a dot product with you have a negative 2y, comma, negative 2x, comma, 1. right? Then we have to be a little bit careful with this because you have a sine of t is there and a cosine of t. So instead of cosine of t and sine of t, so this parameterization goes around the curve clockwise instead of counterclockwise. So it's actually the opposite direction. So we have to put a negative sign in front. So we have to put the negative sign in front, right? Then this is going to be dA, right? And actually, I have to change that too. All right, so this is over the disk D, right? It's actually a unit disk because it's going to go around the unit circle clockwise, so it's going to be D here. All right, so we got that. Then let's compute this. So here, if you compute that, you're going to get this. All right, first, I'm going to distribute this negative sign. So I'm going to turn it into, so this is going to be positive, that's going to be positive, that's going to be positive. So what you get is going to be a double integral over D, right? So this is going to be negative 8 xy squared, right? And this times that is negative 6x cubed, and then it's going to be plus 1, right, with respect dA, right? Then we're going to use a polar coordinate here. So this is over a unit disk, so we know that the r is going to go from 0 to 1. Then the angle is going to go from 0 to 2 pi because you have to go all the way around once. All right, then we just have to put a bunch of things in there. So you have here, right, you're going to have, so it's a negative 8. All right, so x is r cosine of theta. Right, so y squared would be r squared, so this is going to be cubed, and the sine squared of theta, right? Then here would be minus 6. Then we have a r cubed, right? And then you have a cosine cubed of theta. And then we have a plus 1. Then the polar coordinate area element would be r dr d theta. Right, I'm going to actually distribute this r so that you can see that this is going to be, so distribute this r. So this is going to be r, and that's going to be r to the 4th power. This is going to be r to the 4th power. Right, so what you can do is here. Right, so first two terms, there's a r to the 4th, so it's going to be here, 0 to 2 pi, and from 0 to 1, right? So we're going to have r to the 4th power by itself. Then you have negative 8 cosine of theta, sine squared of theta, and a minus 6. Then I'm going to write it this way. I'm going to write a cosine of theta, and then you have a cosine squared, so I'm going to write it as a 1 minus sine squared using a trig identity. All right, and then here we have r left over, so it's going to be plus r. Right, then you have a dr d theta. Right, so first part is separable, so I'm going to go ahead and separate it. So we have integral from 0 to 1, r to the 4th power, dr. Right, then the second part is the integral from 0 to 2 pi. Right, so both of these guys have cosine, so I'm going to pull cosine out, cosine of theta. And then we're going to have negative 8 sine squared of theta minus 6, 1 minus sine squared of theta, right? And then, so this is going to be d theta. All right, this one we have to do it kind of separately. So you have from 0 to 2 pi, and this is theta. And r would be 0 to 1, r dr. All right, so let's compute this. All right, this is going to be, all right, so first part is this is antiderivative is r to the 5th power over 5 from 0 to 1. So this is fairly easy to compute, right? So antiderivative of this, I'm going to use the substitution basically. I'm going to think of u as a sine of theta. Then if you take the antiderivative, you're going to end up getting this, right? So you have, actually maybe let's go ahead and use this substitution. So it's probably better. So here, I'm going to let u equals sine of theta, right? Take the derivative of u with respect to theta, you get the cosine of theta, right? So we know that du is same thing as cosine of theta d theta, right? So we know that here you have a cosine of theta along with d theta is same as du, right? So we have an integral, right? So you have a du, right? All these things is going to be written in terms of u. So it's a 8u squared minus 6 times 1 minus u squared, all that. And then you can see that, let's see, when theta goes from 0 to 2 pi, corresponding u would be, right, sine of 0 is actually 0. And sine of 2 pi is actually 0 too. So you are actually going from 0 to 0, right? So we know that with this integral, we don't really care what the integrand is. This is going to be 0, right? So only thing that's is going to give you anything would be here. So antiderivative of that is theta from 0 to 2 pi. Antiderivative of r is r squared over 2 from 0 to 1. All right, so the first part is this is 0. All right, then what you get is you have 2 pi here times 1/2, which is going to be just pi. All right, so let's type it in. So this came out to be pi, right? Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.